Albert Einstein's story begins not in the towering lecture halls of great universities or in the halls of power, but in the quiet streets of Ulm, a small town in the kingdom of Württemberg in Germany, where he was born on March 14, 1879. His childhood was marked by a mix of silence, observation, and an unusual curiosity that separated him from other children of his age. The world around him often seemed confusing, but his mind, even at an early stage, showed signs of a restless search for patterns and meaning. People who later recalled his early years described him as a child who was slow to speak and sometimes appeared lost in thought, staring into space as if already questioning the invisible order behind everything. To some, he looked like a late bloomer, but to history, he was the spark of a new intellectual revolution. In his earliest years, Einstein displayed what many considered odd behaviors. He was not quick to utter his first words, and this delay concerned his parents. His family even consulted doctors at times, fearing something was wrong with him. Yet when he finally did begin to speak, he often repeated sentences to himself softly, almost like he was analyzing the structure of language before delivering it. This manner of processing, though unusual, hinted at the deep way his mind functioned. He was not one to simply accept words or ideas, but to dismantle and reconstruct them until they made sense to him. This trait, which seemed strange in a small boy, would later allow him to question the accepted truths of science. His father, Hermann Einstein, was a man of quiet determination, running a small electrical business with his brother. His mother, Pauline, was musically gifted, devoted to her family, and known for her discipline. She believed strongly in cultivating her son's mind, though she could not have predicted how far his mind would eventually go. Music became an early companion for the boy, and Pauline's insistence that he learn the violin would shape his life in unexpected ways. To Einstein, music was not just an art, but another language of the universe, a pattern of vibrations and harmonies that mirrored the mathematical rhythm of the cosmos. Later in life, he would say that he thought in music, daydreamed in music, and solved problems in music. As a child, Einstein's sense of wonder was ignited by small, ordinary objects that became extraordinary in his eyes. One of the most famous stories is of the compass his father showed him when he was about 5 years old. While other children might have been amused briefly by the moving needle, young Albert was mesmerized. He could not understand why the needle always pointed north, regardless of how he turned the device. The invisible force that guided it fascinated him, awakening in him a lifelong obsession with the unseen laws of nature. That simple compass became his first window into the mysteries of physics, a clue that the world operated on principles hidden beneath the surface. Unlike many children who accepted play and games as the heart of their days, Einstein often drifted into long silences, asking strange questions or becoming lost in thought. He was not antisocial, but his way of seeing the world did not easily align with the expectations of schoolteachers or relatives. His curiosity was not satisfied with simple answers, and when adults tried to dismiss his questions, he only grew more determined. That curiosity, almost stubborn in nature, became the foundation of his intellectual independence. School, however, was not kind to Einstein in his early years. The rigid structure of the German education system did not suit his personality. Teachers often demanded obedience, memorization, and repetition, but Einstein resisted. He wanted to know the why behind everything, not just the what. This constant questioning irritated his instructors, many of whom considered him a poor student. Some even labeled him lazy or defiant, failing to see the brilliance behind his refusal to conform. His grades were not always impressive, and at times he seemed disinterested in subjects that did not capture his imagination. But when it came to mathematics and physics, his talent became undeniable. He could solve complex problems far beyond the level of his peers, yet even then, he refused to simply follow instructions without exploring alternatives. One of the defining features of Einstein's childhood was his sense of isolation. He was not always comfortable among other children, often feeling misunderstood, Books became his companions, and he devoured works of philosophy and science with an intensity that shocked those around him. He was drawn to the writings of Immanuel Kant and other great thinkers, struggling through their arguments and developing a habit of deep reflection. He learned early on that knowledge was not a set of rules to memorize but a set of mysteries to be unraveled. At home, life was not always easy. His father's business struggled, forcing the family to move several times in search of better opportunities. This instability might have discouraged a less determined child, but Einstein's inner world was so rich that external hardships did not dim his spirit. He continued to question, to read, and to dream. By the time he reached adolescence, he was already nurturing ideas that would later blossom into his revolutionary theories. It was during these formative years that Einstein discovered geometry. The precision of shapes, lines, and angles enchanted him. The idea that one could prove truths with certainty through logic and reasoning was intoxicating. Unlike the rote memorization demanded in school, geometry offered a playground for his imagination and a sense of certainty that appealed to his curious mind. He once described experiencing a holy hour when he first encountered Euclidean geometry, a reaction that few children would ever feel toward mathematics. For Einstein, this was not dry calculation, but a glimpse into the hidden order of the universe. Music also continued to play a central role. His violin was not just an instrument, but a sanctuary, a place where his restless thoughts found harmony. When frustrated with schoolwork or disheartened by criticism, he often turned to music for comfort. Later, he would recall how improvising on the violin helped him think through scientific problems, suggesting that creativity in one field could unlock creativity in another. His rebellious mind did not separate art from science. For him, they were two expressions of the same search for truth. Despite his struggles with formal education, Einstein's intellectual curiosity only grew stronger. He began to teach himself advanced mathematics and physics, often studying far beyond what was expected at his age. His independent learning soon outpaced the curriculum, further alienating him from teachers who misunderstood his attitude. They saw defiance where there was brilliance, laziness where there was independence. One teacher even told him he would never amount to anything. History, of course, proved otherwise. The rebellious streak in Einstein was not limited to academics. He was skeptical of authority in all forms, including political and social. He did not blindly accept rules or traditions, but constantly questioned their purpose. This attitude sometimes got him into trouble, but it also cultivated a sense of freedom that allowed him to think outside conventional boundaries. He did not view authority as an obstacle to be feared, but as a challenge to be examined. The young Einstein also found inspiration in simple thought experiments. Long before he wrote equations, he asked himself profound questions in the form of daydreams. One of his favorite mental exercises as a teenager was imagining what it would be like to ride alongside a beam of light. Could he catch up with it? What would he see if he moved as fast as light itself? These imaginative exercises, which seemed fanciful at the time, would later become the seeds of his theory of relativity. Unlike other students who confined themselves to textbooks, Einstein allowed his imagination to wander to the edges of possibility. His curiosity was not always understood by his peers, who sometimes mocked his daydreaming habits. Yet Einstein was not easily swayed by ridicule. He remained stubbornly committed to his way of thinking, even when it isolated him. This resilience became one of his greatest strengths. He learned to trust his inner voice, to value his questions even when others dismissed them. In many ways, this resilience was just as important as his intelligence in shaping his future. Einstein's early fascination with invisible forces deepened as he encountered the world of electricity and magnetism. His father's electrical business exposed him to the mysteries of currents, wires, and machines, all of which seemed to operate according to hidden rules. While others saw them as practical tools, Einstein saw them as puzzles waiting to be solved. He wanted to understand the principles behind their operation, the invisible connections that made them work. This hunger for deeper understanding would eventually lead him to challenge the very foundations of physics. Even at this stage, Einstein's personality carried a mixture of gentleness and defiance. He was kind and affectionate toward his family, often playing his violin for his mother or helping his father with small tasks. But when confronted with strict authority, he resisted. This duality defined his character, a rebel not for the sake of rebellion, but for the sake of truth. He could respect people, but he would not blindly respect systems or ideas that failed to satisfy his questions. By the time Einstein reached his mid-teens, his unconventional childhood had already shaped him into a thinker unlike any other. He had faced misunderstanding from teachers, struggles in family life, and isolation from peers. Yet these challenges only deepened his independence. He had cultivated habits of self-learning, developed a sense of wonder for the mysteries of the universe, and nurtured an imagination bold enough to question everything. The boy who once stared for hours at a simple compass needle was now a young man staring at the vast mysteries of light and space. His journey had only just begun, but the traits that defined his childhood, curiosity, independence, and defiance of convention, were already setting the stage for the revolutionary discoveries to come. His mind, once dismissed as distracted and stubborn, was in truth a furnace of ideas that would one day light the path for all of modern science. As Albert Einstein moved from early boyhood into adolescence, his spirit of curiosity only grew stronger, but so did the obstacles placed in his path. His family continued to face economic struggles, and the moves from one city to another disrupted his schooling. Yet with each challenge, Einstein's independence became more pronounced. He learned to adapt not by conforming to the rigid structures of the classroom, but by creating his own pathways of knowledge. For him, true education did not come from textbooks alone, but from the relentless pursuit of understanding. At school, his rebellious nature became more visible. Teachers frequently interpreted his refusal to accept authority as arrogance, and he developed a reputation as a troublemaker. He was not violent or disruptive in the traditional sense, but his insistence on questioning instructions or challenging accepted facts frustrated those who valued obedience above all else. One teacher even told him he would never succeed at anything, a statement that ironically highlighted how blind authority can be to hidden genius. Instead of discouraging him, such criticisms strengthened his resolve to trust his own mind. The German education system of his time demanded conformity. Memorization, recitation, and strict discipline ruled the classroom. Einstein, however, refused to learn passively. If a formula or rule was presented without explanation, he would probe, demand clarity, or discard it as unworthy of his attention. This attitude often cost him grades and respect from instructors, but it built a foundation for his later scientific breakthroughs. He was training himself, unconsciously, to value logic and reason over blind acceptance. In this way, his so-called failures in school were in fact exercises in intellectual courage. Outside the classroom, he immersed himself in books that fed his imagination. One of the most influential texts in his youth was a series of popular science books that explained advanced physics in simple language. These writings opened his mind to concepts far beyond his years, such as the nature of light, magnetism, and energy. Unlike his school lessons, these books spoke to his hunger for meaning. He read them again and again, each time drawing new insights. In these pages, the young Einstein found a world of ideas that respected his curiosity rather than suppressing it. By the age of 15, Einstein had developed the habit of conducting thought experiments, imaginary scenarios that allowed him to explore the laws of physics without formal laboratories. One of his earliest and most famous exercises was imagining himself chasing a beam of light. What would he see if he could move alongside it at the same speed? Would the light freeze, or would it still move away? Such questions seemed absurd to many, but for Einstein, they were windows into truths that traditional education never addressed. This ability to question the impossible, to merge imagination with logic, became the hallmark of his genius. Yet adolescence was not free of turmoil. When his father's business failed, the Einstein family faced financial ruin. They moved from Munich to Italy in search of better prospects, leaving young Albert temporarily behind to finish school. This separation was painful, deepening his sense of isolation. Alone, struggling with teachers who misunderstood him, and missing his family, he sank into bouts of frustration. But rather than breaking him, these challenges hardened his independence. He began to see that the conventional path of success, obedience in school, approval from teachers, secure employment, was not his path. He would carve his own. Eventually, Einstein joined his family in Italy, abandoning his schooling in Munich. His time in Italy exposed him to new cultures, new landscapes, and the vitality of art and philosophy. Walking through the streets of Milan and Pavia, he absorbed the richness of human creativity. He studied not because he had to, but because he wanted to, often staying up late with books of mathematics, philosophy, and science. This period away from rigid schooling proved transformative, giving him the freedom to follow his intellectual passions without constraint. It was during this time that Einstein made a critical decision. He would renounce his German citizenship. The rigid militarism and authoritarianism of German society did not appeal to him. Instead, he sought a life of freedom, both politically and intellectually. This choice at such a young age symbolized his deep rebelliousness. Not reckless rebellion, but principled independence. He would not tie his identity to a system that demanded blind loyalty. By the time he entered the Swiss educational system, Einstein's reputation as an unconventional student followed him. Teachers once again found him difficult to control, yet his brilliance was impossible to deny. His mind operated differently from others. He saw connections where others saw only fragments, and he imagined possibilities where others repeated formulas. Even in mathematics, where he excelled, he sometimes frustrated instructors by refusing to follow traditional steps. He often leaped to answers intuitively, skipping the processes that teachers wanted him to show. For him, mathematics was not about rigid procedure, but about beauty and truth. His curiosity also expanded into philosophy. He read the works of thinkers like David Hume and Immanuel Kant, grappling with deep questions about time, reality, and perception. These philosophical reflections intertwined with his scientific curiosity, nurturing his ability to think about the universe in ways few others dared. For Einstein, philosophy was not separate from science, but its natural companion. The great questions of existence could not be divided into academic categories. They demanded unity. Despite his independent brilliance, Einstein's unconventional ways created difficulties in pursuing a career. His professors often overlooked him, considering him too rebellious or unfocused. When he graduated, he struggled to find academic positions, a struggle that would continue into his early adulthood. Yet these struggles trace back to his childhood, where nonconformity became both his greatest strength and his greatest obstacle. Looking back, one can see that the seeds of his later discoveries were already planted in his childhood. His fascination with invisible forces, his thought experiments about light, his obsession with patterns, and his refusal to bow to authority, all of these shaped the man who would later rewrite physics. What others saw as flaws in a child, slowness to speak, stubbornness in school, daydreaming, were in truth signs of a mind unwilling to accept limits. Einstein's childhood was unconventional, not because of dramatic events or grand achievements, but because of the way his mind approached the world. While others saw rules, he saw questions. While others accepted appearances, he searched for hidden realities. While others memorized, he imagined. This spirit of curiosity, nurtured through hardship, misunderstanding, and relentless questioning, was the foundation of his genius. Even as a boy, Einstein demonstrated what the world would later celebrate: the courage to rebel against the ordinary in pursuit of the extraordinary. The child who stared at a compass and dreamed of chasing light was already the rebel mind behind modern science. Though the world did not yet know it, his story reminds us that genius is often misunderstood in its early stages, and that the curiosity of a child, if allowed to flourish, can one day reshape the destiny of humanity. And so, the story of Einstein's unconventional childhood closes not as a tale of struggle alone, but as the birth of a way of thinking that defied convention, challenged authority, and dared to ask the questions that others feared. His rebellion was never against learning itself, but against the limits placed on learning. His curiosity was never about seeking easy answers, but about uncovering deeper truths. These qualities, forged in the fires of a misunderstood childhood, became the very tools with which he would one day open the universe to us all. Albert Einstein's life cannot be understood without considering the tension between his extraordinary mind and the rigid structures of traditional education. From his earliest years in school, it became clear that Einstein was not a child who could easily bend to authority or conform to a system designed for memorization and obedience. His rebellious approach to learning was not born out of laziness or carelessness, as some of his teachers believed, but out of a deep conviction that true understanding could not be reduced to blind repetition of facts. This defiance, often misunderstood in his youth, would later be revealed as the very quality that allowed him to break through the boundaries of conventional science. In the German education system of the late 19th century, schools were built like miniature armies. The emphasis was on discipline, uniformity, and unquestioning respect for authority. Teachers expected students to memorize facts and repeat them word for word, without hesitation or deviation. For most children, this was the path to success. For Einstein, it was a prison. He bristled at the demand for obedience and felt suffocated by the absence of freedom in thought. When others sat quietly, reciting lessons drilled into their memory, Einstein found his mind wandering, questioning, seeking connections beyond what was written on the page. His teachers quickly grew impatient with him. They saw not a budding genius but a troublesome student. He was often labeled lazy or inattentive, accused of lacking seriousness. But the truth was quite different. Einstein was not unwilling to learn. He was unwilling to learn in the way the system demanded. He could not accept knowledge delivered as dogma. For him, every idea had to be tested, every assumption questioned. He could not find satisfaction in the mechanical act of memorization. To his teachers, this attitude appeared rebellious, but for Einstein, it was the only way to keep his curiosity alive. One teacher once told Einstein that nothing would ever come of him, a remark that would be remembered in history with bitter irony. Yet in that moment, it was more than just a comment. It reflected the fundamental clash between a student who sought truth and a system that sought conformity. Einstein later recalled that he felt like an outcast in school, alienated by its rigidity. He once described the schools of his time as places where students were trained like soldiers, taught to march in intellectual formation without question. He wanted none of it. Despite his frustrations, Einstein found occasional solace in mathematics and physics. These were the subjects where his imagination could run free. Even here, however, he often frustrated his instructors by refusing to follow prescribed methods. He could leap to solutions in unconventional ways, skipping the steps that teachers wanted to see. To them, this was a lack of discipline. To him, it was efficiency born of insight. His refusal to conform to expected procedures was simply another expression of his independent thinking. He did not want to show what he already knew. He wanted to push forward to what he did not yet know. The tension between Einstein and his teachers grew over the years, and his rebellious spirit only deepened. By adolescence, he had developed a mistrust of authority that extended beyond the classroom. He questioned not just the content of his lessons, but the very structure of education itself. He saw how the system crushed individuality, forcing students into molds that did not fit them. He recognized that this was not true learning but indoctrination. Einstein's refusal to submit made him unpopular with many of his instructors, but it also strengthened his determination to follow his own path. Outside of school, he sought refuge in independent study. He read advanced works of mathematics and science far beyond the level of his classmates, teaching himself concepts that many would not encounter until university. This act of self-education was another form of rebellion. He proved to himself that he did not need the rigid guidance of teachers to learn. In fact, he could learn better when left to his own devices. He followed his curiosity like a compass, exploring whichever subjects caught his imagination. This freedom brought him joy, in stark contrast to the suffocating environment of school. There is a story often told of Einstein's early school years that captures the essence of his rebellious approach. During one lesson, a teacher demanded that students memorize a passage of text without question. Einstein refused, arguing that there was no value in memorizing words that could easily be looked up in a book. The teacher was enraged by his defiance, but the young Einstein's reasoning was sound. For him, knowledge was not about storing words in memory, but about understanding ideas deeply enough to apply them. This distinction, which eluded his teachers, lay at the core of his genius. The more he resisted the rigid structures of education, the more alienated he became. Classmates sometimes saw him as odd or difficult, while teachers increasingly viewed him as a lost cause. Yet Einstein was not discouraged. He seemed to know even then that the value of education lay not in obedience, but in the freedom to think. He once remarked later in life that it is a miracle curiosity survives formal education at all, a statement that reflected his own struggle to protect his imagination from the weight of authority. By the time his family moved to Italy, Einstein was at a breaking point with the German school system. Left behind in Munich for a time, he felt abandoned and stifled. When he finally joined his family in Italy, he resolved not to return to the authoritarian schooling that had tormented him. He declared his independence not only from his teachers but from the system itself. He renounced his German citizenship, a symbolic act of rebellion that severed ties with the very nation whose schools had tried to suppress him. At an age when most boys were barely beginning to think about their futures, Einstein had already rejected the conventional path laid out before him. This refusal to conform did not mean that Einstein rejected learning itself. On the contrary, his hunger for knowledge was insatiable. But he pursued it on his own terms, in his own way. He spent hours reading scientific works, conducting thought experiments, and working through mathematical problems, not because he was told to, but because his curiosity demanded it. His rebellion was never against knowledge. It was against the narrow way in which knowledge was delivered. In Switzerland, Einstein found a more liberal school environment, yet his rebellious tendencies remained. Even in a system less rigid than Germany's, he still bristled at the expectations of teachers. He continued to prefer independent study to classroom instruction. He showed brilliance in certain areas, particularly physics, but remained indifferent to subjects that did not engage his imagination. This uneven performance frustrated teachers once again, leaving him with a mixed reputation. To some, he was a genius; to others, a lazy and unreliable student. Einstein's rebellious approach to education shaped his worldview in profound ways. He came to believe that true creativity required freedom, and that freedom could not exist where authority was absolute. This belief guided not only his scientific work, but his philosophy of life. He valued questions over answers, imagination over conformity, independence over obedience. These values, nurtured in the fires of conflict with traditional schooling, became the foundation upon which his later discoveries would rest. Even as he moved into adulthood, the scars of his battles with education remained. He struggled to find academic positions after graduation, in part because his rebellious nature had alienated professors who might have supported him. He worked for a time in the patent office, a position far removed from the prestigious academic career he might have expected. Yet this apparent setback became an opportunity. Free from the pressures of academia, Einstein had the space to think independently, to develop the theories that would revolutionize science. His rebellion against traditional education had, in an ironic twist, prepared him for exactly this kind of independence. What others saw as defiance was, in truth, the core of his genius. Einstein understood that blind obedience leads only to repetition, not discovery. His refusal to conform to the demands of his teachers was not an act of disrespect, but an act of loyalty to his own mind. It was this loyalty that would allow him to see beyond the limits of traditional physics, to imagine new realities, and to rewrite the laws of the universe. Thus, the story of Einstein's rebellious approach to education is not simply one of conflict with authority. It is a story of courage, the courage to resist conformity, the courage to defend curiosity, and the courage to believe that true learning is not about memorization, but about imagination. In the narrow classrooms of his youth, he was seen as a problem. In the broad expanse of history, he was revealed as a pioneer. His rebellion was never against knowledge itself, but against the forces that sought to chain knowledge. And in defending his freedom to learn, he defended the very spirit of discovery that drives all of science. Einstein's rebellion against traditional education was not a single moment of defiance, but a continuous resistance woven through his formative years. It began with the early clashes in the German gymnasium, where teachers demanded mechanical learning and blind obedience. It deepened in his adolescence when he abandoned the oppressive Munich school system to join his family in Italy. And it matured in Switzerland, where he would encounter new opportunities, but continue to show the same refusal to bow to authority. This rebellion, far from being a weakness, became the crucible in which his independence and creativity were forged. When he entered the Swiss Federal Polytechnic in Zurich, Einstein found himself in an environment more flexible than the militaristic schools of Germany. Yet even here, his nonconformity remained. He did not attend lectures regularly, preferring to study independently or explore his own interests. While classmates carefully followed every word of the professors, Einstein often skipped classes to spend time in the library or to conduct his own thought experiments. His classmates sometimes resented this, as he would later borrow their meticulous notes before exams, absorbing in days what they had carefully studied for weeks. He passed, often with brilliance in physics and mathematics, but his professors were not impressed by his lack of discipline. They mistook his independence for irresponsibility. This tension between Einstein and his professors would haunt him after graduation. While his classmates received recommendations and opportunities, Einstein was left behind, marked as a difficult student who lacked respect for authority. His professors could not see that his rebellion against their methods was the very trait that would make him a revolutionary thinker. For them, he was an unruly student for history. He was a mind refusing to be chained by tradition. In the patent office, where Einstein found work after his struggles in academia, the same rebellious spirit thrived in unexpected ways. Free from the rigid expectations of university life, he immersed himself in the quiet analysis of inventions. The work required precision but not creativity, leaving his mind free to wander into deeper questions. It was here, outside the walls of formal education, that Einstein developed some of his most important ideas. The young man dismissed by teachers as lazy and inattentive was quietly reshaping the foundations of physics from a small desk in Bern. This story reveals an essential truth about Einstein's rebellion against education. It was never an escape from learning, but a fight for the right kind of learning. He sought understanding, not memorization, imagination, not repetition. He valued curiosity more than compliance, and in doing so he uncovered truths that no obedient student, however skilled in reciting formulas, could have discovered. His rebellion was a rejection of methods, not of knowledge itself. Looking back, Einstein himself often reflected critically on the education system of his youth. He spoke about the danger of schools that kill curiosity, about teachers who demand respect through authority rather than through inspiration. He believed that education should nurture imagination, encourage questions, and allow freedom of thought. His own childhood had shown him what happens when a child's questions are dismissed, and his genius had shown the world what happens when a child's questions are allowed to flourish. His rebellious attitude also extended to the broader culture of science. In a time when many physicists clung rigidly to Newtonian mechanics, Einstein dared to question its foundations. The very habit of thought that had led him to resist his teachers now led him to resist centuries of established authority in physics. The parallels are striking. Just as he had refused to memorize without understanding, he refused to accept the laws of motion and gravity without deeper scrutiny. His rebellion against education was training for his rebellion against scientific orthodoxy. Even his approach to examinations showed his defiance of convention. He often performed brilliantly in the subjects that mattered to him, like physics, while neglecting others he considered unimportant. This unevenness gave his professors more reasons to doubt him, but Einstein cared little for grades or formal success. He was motivated by curiosity, not by approval. To him, exams were obstacles to endure, not measures of true learning. He once remarked that the value of a man lies not in what he has learned in school, but in what he has learned after leaving school. This belief was born directly out of his own struggles with traditional education. The consequences of his rebellion were not easy. For years, Einstein faced rejection after rejection in his search for academic positions. The professors who might have supported him withheld recommendations, unimpressed by his independent ways. Friends and family worried for his future, yet he refused to change who he was. He would not bow to authority just to secure a position. Instead, he continued to pursue his questions on his own, showing a resilience that was as important as his intellect. Einstein's defiance of traditional education also shaped his later role as a teacher and mentor. When he eventually gained academic positions, he did not repeat the mistakes of his own professors. He encouraged students to think freely, to ask questions, and to pursue understanding rather than memorization. He believed that the role of a teacher was not to fill minds with facts, but to awaken curiosity. This philosophy set him apart from many of his contemporaries and made him a beloved figure among students who felt stifled by more rigid instructors. In his later reflections, Einstein often connected creativity to freedom from authority. He argued that imagination is more important than knowledge, not because knowledge is unimportant, but because knowledge without imagination is stagnant. This was not merely a poetic statement, it was rooted in his personal experience. Knowledge given through rote memorization had nearly suffocated him as a child. Knowledge pursued through imagination had freed him as a scientist. His rebellion against education had shown him the difference. Einstein's story is also a warning. How many other children with unusual ways of thinking were dismissed by teachers who valued conformity over curiosity? How many potential geniuses were crushed under the weight of rigid schooling? Einstein himself acknowledged that he had been lucky to survive such a system with his imagination intact. His success was not proof that the system worked, but proof that genius can sometimes resist even the harshest constraints. The irony of Einstein's life is that the very traits that caused him so much trouble in school, his defiance of authority, his refusal to memorize without understanding, his daydreaming habits, were the same traits that allowed him to achieve what no obedient student ever could. His rebelliousness, misunderstood as weakness, was in fact his greatest strength. It protected his curiosity, nurtured his imagination, and prepared him to see the universe in a way no one else had before. And so the story of Einstein's rebellion against traditional education is not only the story of a young man clashing with teachers, it is the story of a revolutionary mind learning to trust itself against all odds. It is a reminder that education, when too rigid, can become an enemy of learning, and that true education must allow space for imagination, for questioning, and even for rebellion. Without that, knowledge becomes lifeless. With it, knowledge becomes discovery. Einstein emerged from his struggles with education not as a broken student, but as a liberated thinker. His rebellion was never about rejecting learning, but about protecting the spark of curiosity that others tried to extinguish. In resisting authority, he discovered freedom. In resisting conformity, he discovered creativity. And in resisting the system, he discovered himself. This is why the rebellious student who once infuriated his teachers became the scientist who forever transformed our understanding of the universe. The year 1905 stands as one of the most extraordinary moments in the history of science, and at the center of it was a young patent clerk in Bern named Albert Einstein. He was not a professor at a prestigious university, nor was he supported by an established institution. He was an outsider, working at a modest desk examining inventions, yet in his spare time he was about to tear down centuries of assumptions about space and time. His rebellious mind, which had once refused to conform to the rigidity of school and resisted the conventions of academic life, was now poised to launch a revolution that would forever alter humanity's understanding of the universe. This was the birth of special relativity, a theory that did not simply refine the old Newtonian picture of the world, but shattered it, replacing it with a vision of reality that seemed almost unimaginable. Einstein's journey to this point was marked by years of private thought, long hours of reflection, and a refusal to accept contradictions within the physics of his time. For centuries, Newton's laws had dominated science, providing a reliable framework for understanding motion, forces, and gravity. Newton's universe was like a grand machine, with time and space as the unchanging stage upon which events unfolded. This view seemed absolute, and for generations scientists built their work upon it. But in the 19th century, cracks began to appear. Experiments on the nature of light, especially the famous Michelson-Morley experiment, suggested something troubling. The speed of light seemed to be constant, unaffected by the motion of the observer. This result did not fit with Newtonian mechanics, which treated velocities as additive. If a train moved forward at 50 kilometers per hour and a man threw a ball inside it at 10 kilometers per hour, an observer on the ground would see the ball move at 60 kilometers per hour. But if light behaved like that, then its speed should change depending on whether the observer was moving toward or away from it. Yet the experiments stubbornly showed otherwise. Light always traveled at the same speed, regardless of the motion of the source or the observer. This puzzle haunted the scientific community. Some tried to explain it by inventing invisible substances like the ether, a mysterious medium through which light waves were thought to travel. Others proposed adjustments to Newtonian laws, but Einstein, working quietly on his own, dared to ask a more radical question. What if time and space themselves were not absolute? What if the very foundations of Newtonian physics had to be reimagined? This was a breathtaking thought, one that seemed almost blasphemous to the scientific orthodoxy of his day. Yet Einstein's rebellious spirit, honed by years of questioning teachers and challenging authority, gave him the courage to follow it. He began with two simple postulates. The first was that the laws of physics must be the same for all observers in uniform motion, no matter how fast they are moving relative to one another. The second was that the speed of light is the same for all observers, regardless of their relative motion. These two principles might have seemed modest, but when combined they unleashed a cascade of consequences that overturned centuries of physics. From them came the realization that time does not flow identically for everyone, that distances can contract depending on motion, and that simultaneity is not universal but relative. The idea that time itself could differ for two people moving relative to each other was shocking. In Newton's world, time was like a universal clock, ticking the same for everyone, everywhere. But Einstein showed that if two observers were in motion relative to each other, their measurements of time would not agree. One's seconds could stretch into another's minutes. This was not a flaw in measurement or an illusion, but a fundamental property of reality. Similarly, distances themselves could shrink when measured from different perspectives. A moving object would appear shorter along the direction of its motion when seen by a stationary observer. These bizarre effects, known as time dilation and length contraction, were not just theoretical curiosities, but natural consequences of Einstein's two postulates. Perhaps the most startling realization was that space and time were not separate entities, but deeply intertwined into a single fabric: space, time. What one observer called space and another called time were, in fact, different slices of the same continuum. The absolutes of Newton had dissolved into a relativity of perspectives, bound together by the constant speed of light. This vision was revolutionary, because it demanded that humanity abandon its intuitive, common-sense view of reality and accept a universe far stranger than anyone had imagined. The consequences of special relativity reached even further. Einstein discovered that mass and energy were not distinct but convertible into one another, leading to his famous equation, E=mc div. This deceptively simple formula revealed that the energy contained within even the smallest amount of mass was immense, capable of powering stars, and eventually nuclear reactions on Earth. At the time, few understood the full implications of this equation, but history would later demonstrate its profound significance. What makes Einstein's work in 1905 even more remarkable is that he accomplished it without laboratories, without assistants, without the resources of a university. He had only his mind, his determination, and his refusal to accept contradictions in the prevailing theories. His rebellious independence, once a source of trouble in school, now became the key to innovation. While others tried to patch old theories to fit new data, Einstein dared to start fresh, building a framework that resolved the paradoxes and pointed the way forward. The publication of his paper on special relativity in the Annalen der Physik was at first met with cautious curiosity. Many scientists found it difficult to grasp, not because the mathematics was impossibly complex, it was elegant and relatively simple, but because the ideas were so radically different from everything they had assumed about reality. It challenged their deepest intuitions. But as the implications became clearer, the scientific community began to recognize that a new era had begun. For Einstein, however, this was not merely an intellectual triumph. It was a vindication of his lifelong belief in the power of imagination and independence. He had shown that even without authority or institutional backing, a single mind, free to question and to dream, could redefine the universe itself. The rebellious student who once walked out of classrooms now stood at the center of the greatest scientific revolution since Newton. And yet, in 1905, Einstein himself could hardly have predicted the full impact of his work. He was still working in the patent office, still an outsider to the academic establishment. The recognition, the fame, and the global influence would come later. At that moment, he was simply a man who had dared to follow his curiosity wherever it led, even when it led to the overthrow of centuries-old beliefs. His special relativity was not the product of privilege but of persistence, imagination, and the courage to rebel against what everyone else assumed to be true. In this way, the story of special relativity is not only about physics, but about the triumph of an independent spirit. It is a story of how the questioning mind of one young man, sitting in a modest office in Bern, could see deeper into the nature of reality than all the established authorities of his time. It is a story of rebellion, not against knowledge, but against the limits placed upon knowledge. And in that rebellion, Einstein gave humanity a new universe, one where time and space are not what they seem, where energy and matter are bound together, and where the imagination of a single human being can stretch as wide as the cosmos itself. When Einstein's paper on special relativity appeared in 1905, it did not create immediate headlines or global recognition. The scientific world at first responded with caution. To many, the ideas seemed counterintuitive, bordering on the impossible. How could time itself slow down? How could space contract? How could simultaneity, that most basic of human intuitions, dissolve into relativity depending on motion? It was a framework that seemed to contradict not only Newtonian mechanics but also common sense. Yet those who studied it closely realized that the equations were rigorous, the logic unshakable, and the consequences profound. It was not speculation, it was a consistent and revolutionary theory that explained results no other framework could. The seeds of Einstein's rebellion against the traditional worldview had now bloomed into a challenge that every physicist had to confront. Some resisted, clinging to the familiar comfort of Newton's absolutes. Others embraced the new theory with excitement, recognizing that science had once again entered a time of transformation. What Einstein had done was not to reject Newton entirely, but to show that Newton's mechanics were an approximation, valid only at low speeds and everyday scales. At high velocities, especially near the speed of light, the universe behaved differently, and Einstein's relativity described it with breathtaking precision. The impact began to spread as scientists tested the predictions of the theory. Time dilation, the slowing of time at high speeds, was not something that could be measured easily in 1905, but the mathematics left no room for doubt. The principle of relativity explained the constancy of the speed of light, resolving the great mystery left unsolved by Michelson and Morley. The idea of mass-energy equivalence, captured in the equation E-mc-dous, was at first just one of many consequences of the theory, but even in its infancy, it hinted at unimaginable power. The stars themselves, burning with seemingly endless energy, could now be understood as natural nuclear furnaces, their light the direct conversion of matter into energy. For Einstein, this revolution was personal as much as scientific. He had labored in isolation, without the support of the academic elite, and now his voice could no longer be ignored. Slowly, invitations began to come. Journals sought his opinions. Universities that once would not hire him began to recognize his genius. Yet Einstein did not allow fame to dilute the purity of his pursuit. He remained at heart the same questioning spirit, guided not by prestige but by curiosity. The rebellion that had carried him through the narrow corridors of education now carried him into the vast expanse of theoretical physics. It is important to imagine the strangeness of Einstein's ideas to those who first heard them. A train speeding past a station was no longer just a train. It was a vessel in which time itself slowed for those inside compared to those standing still. A clock carried on board would tick more slowly than one on the platform. Two lightning strikes that appeared simultaneous to a passenger might not be simultaneous to an observer outside. These were not tricks of perception, but realities built into the fabric of the cosmos. It was as if Einstein had reached behind the curtain of experience and revealed that the world humans thought they lived in was only an approximation, a local shadow of a deeper truth. At first there was skepticism, even ridicule. Some physicists dismissed Einstein as a dreamer, a clever but misguided outsider. Others considered his theory elegant, but doubted whether it would ever be confirmed. Yet the beauty of relativity lay in its clarity. Unlike some speculative theories, it made precise predictions that could be tested, and as the years passed, evidence accumulated. Experiments with fast, moving particles confirmed time dilation. Measurements of moving objects confirmed length contraction. Slowly, reluctantly, the scientific community accepted that Einstein was not rewriting the rules of physics out of imagination alone. He had discovered how the universe truly worked. What makes this period of Einstein's life especially remarkable is how much of it was still lived in obscurity. Even after the publication of Relativity, he continued working at the patent office for several years. While his colleagues read and stamped documents, Einstein's mind drifted through the cosmos, imagining trains moving at the speed of light and clocks slowing down as they raced through the void. There is something deeply poetic in this image. The world's greatest mind, hidden in plain sight, quietly revolutionizing humanity's understanding of existence while working an ordinary job. It is a reminder that genius does not always announce itself with titles or honors. Sometimes it hides in the everyday, waiting for its moment to be recognized. As the theory of relativity gained recognition, Einstein began to travel more widely, giving lectures and sharing his vision of the universe. Audiences were divided between awe and confusion. Many struggled to grasp the implications of relativity, and even fellow scientists sometimes left his talks bewildered. Yet the younger generation of physicists, eager for new ideas, embraced him as a leader of a new era. In the classrooms and laboratories of Europe, the language of space and time was changing, and Einstein's name was on everyone's lips. The broader public soon became fascinated as well. Newspapers began to write about relativity, often with little understanding, but with a sense that something momentous had occurred. Einstein's image, with his wild hair and intense eyes, became a symbol of genius. He had not sought celebrity, but it found him nonetheless. To ordinary people, relativity was mysterious, almost mystical, a science that stretched beyond the imagination. To physicists, it was the foundation of a new worldview, rigorous and exact. To Einstein himself, it was the first step toward an even deeper quest, a unified understanding of all the forces of nature. Special relativity was not the end of Einstein's journey, but the beginning of a greater one. Even as others marveled at his insights, he pressed onward, dissatisfied with the incompleteness of his vision. Special relativity applied only to uniform motion. It did not yet explain acceleration or gravity. To Einstein, this was an unfinished symphony. He knew that space and time had more secrets to reveal, but before he could tackle the force of gravity, he allowed himself a moment to reflect on what had been achieved. In one year, 1905, he had published not only special relativity, but also groundbreaking papers on the photoelectric effect, Brownian motion, and the nature of light, each of which would alone have been enough to secure his place in history. Together, they marked 1905 as Einstein's annus mirabilis, the miracle year, and yet, in Einstein's mind, the work was not a miracle, but the natural flowering of imagination guided by reason. He had not been afraid to question the unquestionable, to discard the most basic assumptions of his predecessors. He had trusted in thought experiments, the playful yet profound exercises of his mind, to lead him to truths invisible to others. His rebellion against authority had become the wellspring of discovery. Where others saw contradiction, he saw opportunity. Where others hesitated, he pressed forward. The acceptance of special relativity transformed Einstein's life. He left the patent office and began a formal academic career. At last, he was no longer the outsider, but the figure at the center of a revolution. Yet he never lost the independence that had defined him. He approached teaching not as an opportunity to impose authority, but as a chance to awaken curiosity in others. He knew better than anyone how education could suppress imagination, and he was determined never to repeat those mistakes with his own students. His lectures were less about dictating answers than about inspiring questions. He became not only a scientist but a symbol of intellectual freedom. In the decades that followed, relativity would be tested in countless ways, from the behavior of subatomic particles to the navigation of spacecraft. Time dilation, once a strange theoretical prediction, became a reality measured by atomic clocks aboard airplanes and satellites. The global positioning system, which guides people across the Earth every day, would not function without corrections for relativistic effects. What had begun as the private musings of a patent clerk became the foundation of technologies that define the modern world. But even in 1905, as the dust of his miracle year settled, Einstein could feel the immensity of what he had begun. He had redefined the stage upon which all of physics was played. No longer was the universe a rigid, mechanical machine of absolute time and space. It was now a flexible, dynamic fabric where motion altered reality itself. This was not only a scientific achievement, but a profound shift in human perspective. The cosmos had become stranger, more complex, and more beautiful, and it was the courage of one rebellious mind that had opened the door. Thus, the birth of special relativity stands as one of the greatest moments in the history of thought. It was the triumph of imagination over dogma, of questioning over obedience, of freedom over conformity. It proved that even the most established truths could be overturned when examined by a mind unwilling to accept contradiction. Einstein's vision of space and time was not just a new theory, It was a new way of seeing the universe. And in that vision, humanity glimpsed not only the workings of the cosmos, but the power of the human spirit itself. When Einstein first proposed special relativity in 1905, he had changed humanity's understanding of motion, time, and space, but he knew the picture was incomplete. Special relativity explained motion at constant speeds, but it did not account for acceleration or gravity. Gravity remained a puzzle, still locked in Newton's vision of an invisible force pulling objects toward one another. For centuries, Newton's law of universal gravitation had reigned supreme, powerful and accurate in predicting planetary orbits and the fall of an apple alike. Yet Einstein could not accept it as the final word. He sensed that gravity was not simply a force acting across empty space, but something deeper, something connected to the very structure of the universe itself. For nearly a decade after 1905, Einstein wrestled with the problem of gravity. He endured long years of failure, countless false starts, and calculations that led to contradictions. His notebooks from this period are filled with restless attempts, scribbles of mathematics, and thoughts that pushed him to the edge of exhaustion. He once described this struggle as some of the most difficult years of his life. And yet, he never gave up. His guiding intuition was simple yet profound. The laws of physics must look the same for all observers, not only those moving at constant speeds but also those experiencing acceleration. If this principle were true, then gravity had to be reimagined in a way that respected relativity. The key came to him in what he called the happiest thought of his life. He imagined a man falling from a rooftop. During the fall, the man would feel weightless. He would not feel gravity pulling him down because he was in free fall. This simple thought revealed a deep truth. Gravity and acceleration were connected. The sensation of weight that we feel is not from an invisible force pulling us down, but from the ground pushing upward against us. Remove the ground, and we float freely, weightless. From this idea, Einstein built what he called the equivalence principle, a cornerstone of general relativity. Over the next years, with relentless determination, he transformed this insight into mathematics. The final theory, completed in 1915, was breathtaking in its elegance and audacity. Einstein proposed that gravity was not a force at all, but the curvature of space, time itself. Massive objects like stars and planets bend the fabric of space, time around them, and other objects move along the curves created by this distortion. In this picture, the Earth does not orbit the Sun because it is pulled by a mysterious force, but because the Sun's immense mass warps space, time, creating a curved path that Earth naturally follows. Space and time were no longer the passive stage of Newton's universe, they were active, dynamic, and responsive to matter and energy. The theory was radical, but it offered predictions that could be tested. One of the most striking was that light itself would bend when passing near a massive object, following the curvature of space-time. In 1919, during a solar eclipse, British astronomer Arthur Eddington led an expedition to measure starlight deflected by the sun. The results matched Einstein's predictions, and the world was stunned. Overnight, Einstein went from being a respected scientist to a global celebrity. Newspapers proclaimed that Newton had been dethroned, and a new vision of the universe had arrived. General relativity was not just a refinement of physics, it was a profound reshaping of human thought. The cosmos was no longer a clockwork of rigid absolutes, but a flexible fabric that bent and curved, a living geometry woven by matter and energy. The implications were immense. Black holes, regions of space where gravity becomes so strong that even light cannot escape, emerged as natural predictions of the theory. The expansion of the universe, later confirmed by Edwin Hubble, found its mathematical foundation in Einstein's equations. Time itself was revealed to be relative not only to motion but also to gravity, running slower near massive bodies than in emptier regions of space. Einstein's general relativity was not only a triumph of physics, but also of imagination. It demonstrated that the universe could not be understood by clinging to familiar intuitions, but required the courage to follow abstract principles, wherever they led. What began as the simple image of a man falling from a rooftop grew into a vision of the cosmos that still guides modern science. Satellites in orbit, GPS systems, and explorations of deep space all rely on the corrections predicted by general relativity. Without Einstein's insights, modern technology and astronomy would falter. The story of general relativity is also the story of perseverance. For years Einstein stood alone, doubted even by colleagues who had admired his earlier work. The mathematics was daunting, the concepts alien, and the resistance from the scientific establishment strong. Yet Einstein's stubborn independence, his refusal to accept compromise, carried him through. He trusted his intuition when others doubted him, and his determination transformed struggle into triumph. In the end, general relativity became not only one of the greatest scientific achievements in history, but also a symbol of the human spirit's power to imagine beyond limits. It showed that reality is stranger, deeper, and more beautiful than common sense suggests. It showed that a single mind, driven by curiosity and courage, could reshape humanity's place in the cosmos. Einstein had redefined gravity itself, turning what once was seen as a simple force into a profound dance between matter and space-time. And in doing so, he gave the world a new universe, one that continues to inspire wonder a century later. By the 1920s, Albert Einstein had become a towering figure in science, celebrated worldwide for his theory of relativity and his reshaping of gravity into the geometry of space-time. Yet the universe was not finished surprising him. A new frontier was opening in physics, one that dealt not with stars, planets, and galaxies, but with the mysterious and invisible world of atoms and subatomic particles. This was the strange, uncertain world of quantum mechanics. While Einstein had helped launch this revolution with his work on the photoelectric effect in 1905, he grew increasingly uneasy with where the new theory was heading. What began as his contribution became a battle, one of the most dramatic intellectual struggles in the history of science. Quantum mechanics emerged from experiments that defied classical expectations. Light, which had been thought of as a wave, sometimes behaved like a stream of particles. Electrons, which were thought of as particles, showed interference patterns like waves. At the heart of these mysteries was the realization that at very small scales, nature does not behave in the predictable, deterministic way Newton envisioned. Instead, it followed rules of probability. Werner Heisenberg, Niels Bohr, and others developed a mathematical framework suggesting that particles did not have definite positions and velocities until they were measured. Heisenberg's uncertainty principle declared that certain pairs of properties, like position and momentum, could never be known precisely at the same time. Reality, according to this view, was not a fixed clockwork, but a shifting fog of possibilities. To many, this was thrilling. Bohr and his followers in Copenhagen embraced the idea that quantum mechanics was not just a new theory, but a new philosophy of nature. They argued that uncertainty was not due to human ignorance, but was built into the universe itself. Atoms did not exist as solid objects with definite paths. Instead, they existed as clouds of probability, only crystallizing into definite states when observed. This was the so-called Copenhagen interpretation, and it quickly became the dominant view. But Einstein could not accept it. For Einstein, the very essence of science was the search for order, law, and clarity in nature. He had spent his life uncovering hidden simplicity beneath apparent complexity. To now accept that reality itself was fundamentally uncertain, that God played dice with the universe, was something he found deeply troubling. He famously remarked, "God does not play dice," a phrase that captured his lifelong discomfort with the idea of chance as the ultimate foundation of physical law. Einstein did not reject quantum mechanics outright. In fact, he admired its successes in explaining phenomena that classical physics could not, but he insisted that the theory was incomplete. For him, the strange probabilistic behavior of particles must conceal a deeper, hidden reality that scientists had not yet discovered. He believed there must be hidden variables, unseen laws that would restore determinism and order to the microscopic world. This intellectual battle reached its height in the famous debates between Einstein and Bohr during international physics conferences in the late 1920s and 1930s. These exchanges have become legendary in the history of science. Einstein would propose thought experiments designed to reveal contradictions in quantum mechanics, clever setups that, he hoped, would show that uncertainty could not be a fundamental principle. Each time, Bohr countered with equal brilliance, defending the strange new logic of quantum theory. The debates were intense but respectful, marked by deep mutual admiration even as their philosophies clashed. To witnesses, it was like watching two titans wrestle not just with equations, but with the very meaning of reality. Einstein's most famous challenge came in 1935 with the paper he co-authored with Boris Podolsky and Nathan Rosen, known as the EPR paradox. In this thought experiment, they described two particles that interacted and then flew apart. According to quantum mechanics, the two particles remained mysteriously linked, or entangled, such that measuring one instantly determined the state of the other, no matter how far apart they were. To Einstein, this implied spooky action at a distance, something he considered absurd. He believed this showed that quantum mechanics was incomplete and that a deeper theory must explain such correlations without violating the principle of locality. Bohr disagreed, insisting that entanglement was real and that the paradox highlighted not a flaw, but the very essence of quantum mechanics. For decades, the debate remained unresolved. Only in the latter half of the 20th century, long after Einstein's death, did experiments by physicists such as John Bell and Alan Aspect confirm that entanglement was real and that quantum mechanics, as strange as it seemed, was correct. In a sense, Bohr had won the debate, and yet Einstein's challenge was not in vain. His insistence that the theory was incomplete inspired generations of physicists to probe deeper into the foundations of quantum mechanics. Even today, debates continue over the meaning of quantum reality, with interpretations ranging from many worlds to hidden, variable theories that echo Einstein's vision. His discomfort forced the scientific community to ask harder questions, ensuring that quantum mechanics was not just a set of equations, but a profound puzzle about the nature of reality itself. The clash between Einstein and quantum mechanics was not just a scientific disagreement, it was a philosophical confrontation. It raised questions about whether the universe is fundamentally orderly or governed by chance, whether reality exists independently of observation, and whether science's ultimate goal is prediction or understanding. For Einstein, these were not abstract puzzles, but central to the dignity of science itself. His refusal to accept randomness as the final answer was an expression of his lifelong quest for unity, for a cosmos ruled by harmony rather than chaos. In the end, Einstein's rejection of quantum indeterminacy became one of the paradoxes of his life. The man who had shattered classical certainty with relativity now resisted the uncertainty of the quantum world. Yet his resistance was not born of stubbornness but of principle, a conviction that nature's secrets were deeper than equations of probability. Even as the physics community moved on, Einstein continued his lonely search for a unified field theory, one that would reconcile relativity and quantum mechanics into a single, harmonious vision. He did not succeed, but his struggle left a legacy that continues to shape science. The story of Einstein and quantum mechanics is a reminder that science is not just about answers, but about the courage to ask questions that challenge even the most successful theories. It shows that disagreement, far from being a weakness, is a driving force of progress. In his debates with Bohr, Einstein helped define the very soul of 20th century physics. And though history may say that he lost the battle, his refusal to accept easy answers ensured that the mystery of the quantum world remains alive, inviting each new generation to wonder whether the universe is truly governed by chance or by laws yet undiscovered. Albert Einstein's contributions to science extended far beyond the theories he personally developed. They transformed the entire framework of modern physics and laid the foundation for technologies that define the world we live in today. When he first introduced the theory of special relativity in 1905, few could have predicted that his ideas would ultimately reshape not just scientific understanding, but the very infrastructure of modern society. His genius was not only in his discoveries, but in the way those discoveries opened new doors, inspiring generations of scientists and engineers to build upon his vision. One of Einstein's earliest breakthroughs, his explanation of the photoelectric effect, seemed at the time like a small step in understanding how light interacts with matter. In reality, it opened the pathway to quantum physics and became the cornerstone for technologies like solar panels, digital cameras, and countless electronic devices. This was the discovery that earned him the Nobel Prize in 1921, though at the time it was overshadowed by his relativity theories. Today, the ability to harness light in the form of solar energy is one of humanity's most powerful tools against climate change, and the principles behind lasers, fiber optics, and medical imaging all trace back to that same groundbreaking insight. His theory of relativity, often thought of as abstract and distant from daily life, has also become deeply practical in ways Einstein himself might never have imagined. Time dilation, one of the key predictions of relativity, is essential to the accuracy of GPS satellites that guide navigation in cars, airplanes, and smartphones. Without relativity, global positioning systems would drift by kilometers each day, rendering them useless. What once seemed like an exotic consequence of moving close to the speed of light now quietly operates in the background of modern civilization, guiding shipping fleets, emergency responders, and even farmers using precision agriculture. Einstein's general relativity also gave birth to modern cosmology. Before Einstein, the universe was seen as static and eternal, but his equations suggested otherwise. They predicted a dynamic cosmos, one that could expand or contract. Though Einstein himself at first resisted this conclusion, later observations by Edwin Hubble proved that the universe was indeed expanding, giving rise to the Big Bang theory. This reshaped humanity's understanding of its place in the cosmos, and it continues to guide astronomy today. Without Einstein, modern astrophysics, black holes, gravitational waves, the expansion of the universe would be unimaginable. In fact, the detection of gravitational waves in 2015, a century after Einstein predicted them, became one of the most profound scientific triumphs of the modern age, confirming not just the brilliance of his theory, but the enduring relevance of his vision. His intellectual courage also shaped the trajectory of quantum mechanics, even though he disagreed with its philosophical interpretation. By questioning the completeness of quantum theory, Einstein kept alive a tradition of skepticism that pushed scientists to refine and test the theory more rigorously. His EPR paradox, while originally a critique, became the seed for one of the most revolutionary fields of science, quantum information. The strange phenomenon of entanglement, which Einstein once dismissed as spooky action at a distance, is now the basis for quantum computing and quantum cryptography, technologies that may one day revolutionize communication, security, and problem-solving on a global scale. Einstein's work also influenced the development of nuclear energy and weapons, though this connection weighed heavily on his conscience. His famous equation, E=mc², revealed the vast energy hidden in matter, a principle later harnessed in both nuclear power plants and atomic bombs. While Einstein did not directly build these weapons, his 1939 letter to President Roosevelt, warning of Germany's potential nuclear program, helped spur the Manhattan Project. After the war, Einstein became a leading advocate for peace and nuclear disarmament, demonstrating that he understood the moral weight of science as well as its potential. His scientific insights thus became a double-edged sword, capable of both great progress and great peril, and his voice helped guide the ethical discussions that continue today about science's responsibilities. Beyond direct technologies, Einstein's style of thinking reshaped how science itself is done. He taught the world that imagination is as important as calculation, that bold ideas can emerge from thought experiments just as much as from laboratories. His method of challenging assumptions, asking "what if" questions, and daring to question the deepest principles of physics inspired generations of scientists. From theoretical physics to computer science, from medicine to engineering, Einstein's intellectual legacy encouraged innovation and creativity as the engines of discovery. Even the cultural image of the scientist owes much to Einstein. With his unkempt hair, thoughtful eyes, and playful wit, he became the embodiment of genius in the 20th century. But this image was not just symbolic, it reflected the way his ideas captured the imagination of the public. Science, which had once been seen as the domain of a few specialists, suddenly became a matter of fascination for ordinary people. Einstein showed that the deepest mysteries of the universe could be contemplated by anyone willing to think differently. This cultural impact helped inspire young people across the world to pursue science, ensuring that his legacy was not only in discoveries but in the minds he awakened. Modern science and technology are unthinkable without Einstein's contributions. From the devices in our pockets to the satellites above us, from our understanding of the universe's birth to the emerging power of quantum computing, his fingerprints are everywhere. His theories did more than explain the cosmos, they gave humanity tools to navigate, explore, and shape the future. Even in medicine, technologies like MRI machines, which rely on the physics of relativity and quantum mechanics, stand as quiet monuments to his influence, saving countless lives every day. Einstein's role in shaping modern science was not limited to the past. It continues to ripple forward, as physicists seek to unify relativity with quantum mechanics into a theory of everything. They are continuing the very quest Einstein devoted the last decades of his life to. Though he did not solve it, he pointed the way, reminding the world that science is never finished, that each breakthrough is a stepping stone to deeper mysteries. In the end, Einstein's impact was not only in the specific theories he developed, but in the culture of curiosity and boldness he embodied. He showed that one person, armed with imagination and determination, could change the destiny of science and technology. His legacy is not just equations on paper, but the entire framework of the modern world. As we look to the future, from exploring distant planets to building machines that compute in ways we cannot yet imagine, we continue to walk in the path he helped clear, guided by the light of a mind that dared to rebel against convention and in doing so reshaped the very story of science. Albert Einstein's legacy is not confined to the realm of equations, blackboards, and scientific journals. His name has become a synonym for genius itself, and his influence stretches far beyond physics, touching philosophy, culture, politics, and even the way humanity perceives itself in the universe. More than any other figure of the 20th century, Einstein embodies the idea of the revolutionary thinker, someone who challenged the accepted wisdom of his time and left behind a legacy that continues to shape our world long after his passing. When we speak of Einstein, we are not only speaking of relativity or quantum debates, we are speaking of a man who redefined what it meant to question reality. His theories reshaped humanity's understanding of space, time, and matter, but his deeper legacy lies in the method he embodied: the courage to defy convention, to imagine what seemed impossible, and to pursue truth no matter how unpopular or unlikely it appeared. He showed that progress often comes not from following rules, but from breaking them, not from accepting limits, but from seeing beyond them. In this sense, Einstein was more than a scientist, he was a symbol of intellectual rebellion, of the creative power of a free mind. His scientific contributions themselves continue to live on in every corner of modern research. The theory of relativity remains the backbone of astrophysics and cosmology, guiding our exploration of black holes, gravitational waves, and the structure of the universe. His insights into the photoelectric effect underpin technologies that have transformed daily life, from solar power to digital imaging. His curiosity about light motion and energy laid the groundwork for everything from GPS navigation to nuclear energy. The fact that discoveries made more than a century ago are still shaping new innovations, is itself a testament to the enduring power of his ideas. Einstein's legacy is written into the very fabric of our modern world, both in visible technologies and in the invisible frameworks of knowledge that guide science. But Einstein's legacy was not confined to laboratories or lecture halls. He became one of the first scientists to transcend academic boundaries and enter the realm of public thought and culture. His face, with its wild hair and twinkling eyes, became one of the most recognized images of the 20th century. His words, often delivered with simplicity and humor, became sources of inspiration far outside physics. Quotes like, "Imagination is more important than knowledge," or "The important thing is not to stop questioning," continue to inspire people across generations, encouraging curiosity and creativity as universal values. In this way, Einstein bridged the gap between science and the broader human spirit, reminding the world that discovery and wonder are not just for specialists, but for everyone. Einstein's influence also extended into moral and political spheres. He lived through 2 world wars, the rise of fascism, and the nuclear age. His equation E=mc², which revealed the immense energy locked inside matter, indirectly paved the way for nuclear weapons. This burden weighed heavily on him. Though he had signed the letter to President Roosevelt in 1939 urging the United States to investigate nuclear weapons before Nazi Germany could develop them, he later regretted this role and became one of the most prominent voices for peace and disarmament. In the years following World War II, Einstein used his global reputation not to promote scientific triumphs, but to warn of the dangers of unchecked technological power. His advocacy for peace, his outspoken opposition to racism, and his support for humanitarian causes became integral parts of his legacy. He was not content to remain in the ivory tower of science, but instead embraced the responsibility of being a citizen of the world. The lasting influence of Einstein also lies in the inspiration he gave to other thinkers and dreamers. His life story, from a curious child who questioned his teachers to a global icon who reshaped science, became a model for how intellectual courage can change history. Generations of students have looked to him not just for scientific insight, but as proof that rebellion against rigid systems can lead to progress. He demonstrated that imagination, persistence, and the refusal to accept limitations could open entirely new worlds of possibility. To this day, Einstein's image is invoked whenever we speak of human potential, of the power of thought to transform reality. In the cultural imagination, Einstein became more than a scientist, he became a metaphor. To call someone an Einstein is to call them brilliant, creative, or visionary. His name has entered language itself, a rare achievement for any individual. Movies, books, art, and even popular humor often reference him, a sign that his impact extends beyond technical knowledge into the shared fabric of global culture. Unlike many scientific figures who remain unknown outside academia, Einstein achieved something extraordinary. He became a part of collective memory, a universal symbol of genius and curiosity. And yet, perhaps Einstein's greatest legacy is the spirit of inquiry he left behind. He showed that science is not a fixed body of knowledge, but a dynamic journey, always evolving, always questioning. He accepted that his own theories might one day be overturned, insisting that truth was larger than any individual. In this humility, combined with his boldness, Einstein left an example of how to balance confidence with openness, conviction with curiosity. He reminded the world that science is not about final answers, but about the courage to keep asking deeper questions. Even today, as scientists explore mysteries Einstein never solved, like unifying relativity with quantum mechanics or understanding the nature of dark matter and dark energy, his influence can be felt. These efforts are not only inspired by his specific work, but by his vision of a universe governed by beauty, unity, and order waiting to be discovered. Every new telescope scanning the cosmos, every particle collider probing the subatomic world, and every experiment searching for the hidden laws of reality is, in some way, a continuation of Einstein's quest. In the final measure, Einstein's legacy is not just scientific, technological, or cultural, it is human. He showed that one person's mind, when freed from fear and dogma, can change the destiny of humanity. He showed that rebellion, when guided by imagination and reason, can unlock truths that alter the course of civilization. He showed that science is not a cold pursuit of equations, but a profoundly human endeavor, driven by wonder, creativity, and the longing to understand our place in the universe. His life was proof that the most revolutionary ideas often come from those willing to stand apart, to think differently, and to dream of what others consider impossible. Albert Einstein remains one of the greatest figures in history because he was more than a scientist. He was a revolutionary thinker whose legacy continues to inspire curiosity, imagination, and courage across the globe. As long as humanity continues to search for meaning and knowledge, Einstein's name will remain a guiding light, a reminder that the universe opens its secrets not to those who conform, but to those who dare to question.